And you know, like on my dashboard, like up here, there's like a bunch of holes, and it went in the holes. Yeah, your car's messed up. It's gonna be another 8,000 in the peak. No, it wouldn't break anything. It was just holes.
The
It was just like in like the little holes on the dash. I think that's where the air comes out.
yeah, it's your defroster most likely.
Yeah. It's gonna melt. I could feel it. It didn't go all the way down. I can try and grab it.
Or if you're lucky and it's light enough, you could turn defrost on full. And it might, if it's light enough and it can catch air enough. Yeah, I mean, most things, the air system, as long as it doesn't get into the fan, you should be fine. Because, random story, when my parents got married, I think it was, I can't remember who, but they did is kind of they throw rice. It's always kind of the deal. They snuck in underneath their car and put it where rice was in the air system. So when they turned their car on, they set it to full blast. So it just, all the vents just shot rice out.
I saw someone do that with baking powder.
But the downside is because if you've ever seen the air tubes or whatnot, they're not solid. There's little creases. So apparently rice had gotten stuck in some of those. So they said for years afterwards, you'd feel something hit you, and it was some piece of rice finally got loose and came shooting out of the vent. So it's funny, and it's like even years later after they sold it, it was still throwing rice every now and then.
The next person that imagine you're driving the new car you got and you're like, what's the throwing rice? Oh, this is such a nice car.
All right, guys. Before we get started, are there any questions over the homework?
Yes.
Question number?
I don't know if I could.
Number 8? Because I think this was the starting problem. Yeah. Because they're off the same sheet. Now, all right, guys. Now, number 8 on 661. So 36 we need to rewrite as 6 to a power. All right, guys. So for 36, we rewrite it as 6 to a power. So the bases are the same. So the one side we'd have 6 to the 2x minus 6. The other, we need to distribute the 2. So 2 times our 3x is 6x. And 2 times negative 5 would be negative 10. Now, since the bases are the same, the exponents have to be equal. So we'd say 2x minus 6 is equal to 6x minus 10. Now, at this point, there's several different ways we could go from this here. We could add 6 to both sides. We could add 10 to both sides. We could subtract 6x. We could subtract 2x. It doesn't matter which one we do first. We just need to pick one of them. I'm just going to subtract 2x. Because what that'll tell me is that negative 6 is equal to 4x minus 10. At this point, we can add 10 to both sides. Minus 4x is equal to 4. Divide by 4, telling us x is equal to 10. Because if you subtracted 6 or added 6 first, and then subtracted the 6x, you should have got negative 4x equals negative 4. And then divide by negative 4 and you get, yeah, so that'd be x. Negative 4 divided by negative 4 is
0?
anything divided by itself is 1.
Oh,
The negatives cancel out.
Yeah.
So it would have been the same.
It would have been the same thing.
So I just did that.
Because again, as I said here, we just need to pick one of them to do first. So if we would have added, so instead of subtracting 2x, we subtracted the 6x, added the 6, we would have gotten negative 4x equals negative 4. But it still tells us x is 1. It's different ways to get to the same spot. We just have to pick at this point here what I'm going to subtract or add, and then go from there. So if I add the 6 first, it means in the step here I'd be subtracting 6x. It just depends on what we move. We'll get to the same place. We just have to pick a set of steps to go first. Does that make sense?
yes. And this one,
That just,
told me, yeah, it was just negative 15 over 9.
what goes into both 15 and 9? So that actually reduces to what? What's negative 15 over 9? Yeah, it just reduces. Questions on this here? All right, guys. Our first problem is this one here. 2 to the x is equal to 7. 2 to what power is 7? 2 to the 1.5 is,
It's uneven. It's not
so there's not an integer number or a nice number that works out for this here. So we have to use logarithms. Now, it's going to seem a little bit weird at this point, but I'm going to apply log base 2 to our 2 to the x. Now, we'll look at the other side here in a minute, but I want to look at this here first. Because log base 2 of 2 to the x, according to our logarithmic properties, we can move that exponent to the front. It's our power property, which tells us that we have x times log base 2 of 2. Now, the reason this is nice and the reason we're doing this is based off of this property here. Log base b of b equaled what? 1. So that tells us here if the base and what's inside of it are the same, it equals 1. It means that our log base 2 of 2 is what? 1. And what's 1 times x? Just x, yes? So if I apply log base 2 to our 2 to the x, the base and what's inside are the same, it's just going to reduce to x, yes? Now what we do to one side, we have to do to the, so the other side is going to be log base 2 of 7. Because if I apply log base 2 to one side, well, we have to apply it to the other side, yes? Now we can calculate and approximate this. We can do this in the graphing calculator. We can clear all that out. Because if we remember doing this here, to get that, we can go math and go up to log base 2 of 7 is 2.807. So it's approximately 2.807. And really, if we're writing this correctly, it would be not our actual equal sign, but our squiggled kind of equal sign, because it's approximate, it's not exactly 2.807. Because in the calculator, if we said 2 to the 2.807, it is close to it. It's not exact. Because we would need 2 to the 2.807354922. And that's not the exact answer. It does extend on out further, but it starts approximating at that point. But that's it. No, I'm not going to be too concerned with that there. But especially on the test, and I think I'm going to have y'all just take it to this point here and not make you try to calculate it out. Because even if you do give me the decimal answer and you're not quite sure, if you do give me the log base 2 of 7, I will take that. Even if it turns out that your answer here was completely wrong due to most likely typing it in or some error there, I will check your log base before you type it in. Does that make sense? And if you wanted to, especially the homework for this here, you get them all to this point here and then calculate them all later, that's fine too. Questions on this here? Now, we won't see this too much. We won't see anything where we have to get it by itself. But if we had anything attached to our term, so 3 to the x, that base where the variable is in the exponent, we need it by itself. So we'd have to subtract 2. We'd have to do things to get it by itself. Now, for us here in the first summary we're going to do, we're not going to have to worry about that. Because here, the number with the variable in the exponent is already by itself, yes? And we want to find x. Now, what are we going to do? Almost. Log base 3 of 3 to the x is equal to log base 3 of 8. Now we use log base 3 because our one side is 3 to the x. So I'm going to write this out again because the x goes to the front, telling us that we have x times log base 3 of 3 is equal to log base 3 of 8. And as we've seen it, we saw it here a minute ago, math, log base 3 of 3 is 1. So this here is, for all intents and purposes, 1, leaving us with x is equal to log base 3 of 8. This is approximately 1 point.
It's 27, but round to.
Yep. 1.8927. So it would be 3. Yes. Questions on this here? And this answer, especially with this here, does make sense because we're saying 3 to what power is 8? Yes. What's 3 to the second power? 3 squared. 3 to the first is 3. So whatever that exponent is has to be between 1 and 2, yes? Because 3 squared is 9. Well, it's close to 9. So it's going to be something close to it. Does that make sense? Yeah, it's a little funny that it works that way, but that's really it. Now, we can't as easily do that with this here because the exponent, in this case, is not just x. It's 9x, yes? Well, 7 squared is 49. 7 to the first is 7. So again, we're looking somewhere probably between 1 and 2 if it was just x. 9x is going to make it a little bit different for its value, not the steps. What is the first step we would do? log base 7. And we're picking log base 7 because the base, the number what that exponent with the variable is attached to is 7. Because log base 7 of 7 reduces log base 7 of 7 to the 9x is what?
Oh, you just, I guess,
9x, because the log base 7 of 7 simplifies, yes? I did it on the first two and wrote it out so that we can see that, because that's really what we have. The 9x moves to the front. Log base 7 of 7 becomes 1, leaving us with 9x. Since we know that already, we can just rewrite it as 9x. And the other side stays log base 7 of 15. Questions on this here? Is x by itself? No. So what do we need to do to get x by itself? Divide both sides by 9. Telling us that x is log base 7 of 15 over 9. Now, if you don't have a graphing calculator that can do log base for us, we can use the change of base formula for our logarithm. And the change of base just says that log base b of m is equal to log of m over log of b. Log of what's inside divided by log of the base to calculate this. So if I wanted to, the top would be log of, I just lost the number, 15, because that was it, what was inside, over log of our base, which was 7 all over 9, because our log base 7 of 15 is log of 15 over log of 7, and we divided the whole thing by 9. And we got 0.1546 or 1, our x is approximately 0.155.
So
Now in the graphing calculator, we can go alpha y equals enter math log base 7 of 15 all over 9, and we do get the exact same decimal. Be careful you didn't do 15 over 9, would be my guess. Yes?
So why did it work when I did this? I just want to.
So it's approximating. So it's approximating the log base 7 of 15, and then it's taking that approximation and dividing it by 9. For most of what we'll do, it's not going to make a big difference since we're rounding to the third. But if we round too many times, it starts getting farther and farther away from it. Does that make sense? Yes. Mm-hmm. Yeah. So the biggest thing I would say is get it all the way down. Simplify it all the way, or kind of solve it all the way for x and then type it all in at once. Yes. Because it rounds to 0.155. Because we could do this and say divide by 9, and we do get something close to it. So you see that there. So I calculated then say divide by 9, we could do that. And ANS is just the previous answer. So it's not taking it and rounded where we're typing it in. It's taking what the actual value is and using it to calculate a little bit closer. But again, it'd be good to write that out just in case you do have a rounding error or something there. Because if you're not sure, I will take that as the correct answer, even if your calculator version of the answer is not the same. Does that make sense? Because at that point, it's not so much that you didn't know how to do it, it's just the calculator. There's a typing, something got typed in wrong. What's the first thing we can do here? Log base 5 of 5 to 3x plus 7 is equal to log base 5 of 311. Well, the right-hand side is still going to be log base 5 of 311. What would be, or what is log base 5 of 5 to the 3x plus 7? Just 3x plus 7, because the log base 5 of 5 is 1, it simplifies it. Yes. Questions on this here? Is x by itself? What do we need to do? We are going to need to divide at a certain point. I would save it to the end. Subtract 7, because we want to move the 7 first. Because dividing by the 3 would not be wrong at that point. It's just going to make it a little more challenging. Because we would divide the 3x, we would have to divide the positive 7 and our log. So then the x would be by itself plus 7/3 equals log base 5 of 311 over 3. Might as well save division for the end so we're not having to deal with as many different components to it. Questions on how we got to this point here? Alpha, y equals enter. Math. Log base 5 of 311 minus 7 all over 3 negative 1.145 when we round to the nearest third decimal. That's it. Questions on this here? What would we do first? Log base 7 to both sides. Log base 7 of 7 to the 5x plus 3 would be 5x plus 3, because we know log base 7 of 7 reduces to 1. So it simplifies. On the other side, we have log base 7 of 312, yes? If we want, we could see math, log base 7 of 312, see if it gave us a nice number. If it did, that would be nice, but unfortunately, it doesn't. So we can continue on with our steps, which would be exactly minusing 3, telling us 5x is equal to log base 7, 312 minus 3. And then our next step would be to divide both sides by 5. minus x is equal to log base 7 of 312 minus 3 all over 5. Where x is approximately negative 0.010, because I think it's negative 0.009. Yep. Very good. And a student second hour was telling me that, and I was fumbling all over it, trying to understand what they were saying. But questions on this here? I definitely need to fix this slide and make sure all this extra stuff is covered up. All right. What would we do first?
Log base of 36.
Log base 36 of 36 to the 12x minus 5 is equal to log base 36 of 40, 26. On the right hand side, it's still going to be log base 36 of 40, 26. On the left hand side, it would be what? It would be 12x minus 5, because our log base 36 of 36 is 1, and it'd be 1 times our 12x minus 5, which is just 12x minus 5. To solve for x, we would then add 5 to both sides. So I said 12x is equal to log base 36 of 40, 26 plus 5. And last but not least, we would divide both sides by 12. Telling us x is equal to log base 36 of 40, 26 plus 5 all over 12. That's it. Questions on this here? Now this one here is a little bit different. Not so much that we have e as the base, but we have other things with it for the first time. Because we have 4 times our e to the negative 0.3 minus 7 equals 13. Before we can apply the base, or our logarithm, to this, we need the term with the variable as an exponent by itself. Well, what can we do to get that term by itself? Almost.
Oh, add 7, sorry.
We would add 7. Since the 7 is negative, we would add it to both sides, because our negative 7 plus 7 would be 0. Leaving us with 4e to the negative 0.3x is equal to 20. What would we do next? We will, but we need to do something else first. We need to move the 4, because we need that e by itself. We could apply the natural log, but it would have to be split up, because that 4 is there. It's going to make it easier if we divide both sides by 4. because our 4 divided by 4 is 1, giving us e. 20 divided by 4 is 5. Now we're going to apply our log to both sides. We could say log base e, but we don't say log base e. We say ln, our natural log, because the natural log's base is understood to be e. Now, as we did in the previous ones, I'll write this out, because again, we would move the negative 0.3 to the front, leaving us with our multiplication of ln of e. Yes? What is ln of e? 1. The natural log of e is 1. So it's, I don't know why I lost the x there. Negative 0.3x is equal to ln of 5. Last but not least, we're going to divide by negative 0.3. Telling us that x is equal to the natural log of 5 divided by negative 0.3. Now, natural log is nice because we can do it in either calculator. Natural log of 5 over negative 0.3. Negative 5.365.
What did I do wrong? Because it didn't let me do that.
Let me see. I believe that is enter
Okay, that's a thing.
with the negative.
Oh.
Yep. Negative 5.365. Yep. Questions on this here? We'll finish this tomorrow.